Right, everyone, welcome back. So this is week 6. Um, so I would like to spend some time to go some specific topics, especially some of the challenge question. Let me go back here. So actually, they are cover pretty much of all these chapters. Oh, someone is just logging. Sorry, just go back. Okay, so most of just like we say, um, you can do up to now. You guys do about 4 sets of practice, SAT practice. You can see majority of them they do have equations, inequalities, functions, linear functions like slope, like y-intercept, x-intercept. Actually, real problem, right? And system inequality. Right now, we met two of the system inequality, exponent, polynomials, and I believe a lot of people do very good about factor polynomial part in factoring because we teach pretty much in detail about how to get a polynomial factoring, right? Okay, so you can see a lot of topics here. Majority here, top part is from algebra 1. And I think most of people, a lot of you guys, a little bit challenge for you is quadratic equation function, as well data analysis and possibility. Actually run last couple of weeks ago, I tried to introduce you this data analysis possibility. Majority from the chart and probability part actually pretty hard. Sometimes here just touch very basic part, something like select somewhat like possibility is very basic part. And we may, if we whenever met the kinds of question which will go a little bit more detail, and exponential functions and radical functions, these two in the algebra 2 sometimes a little bit challenging. And like the one earlier one we have two questions about 55%, right? The earlier one, and rational function and equations, and these are all related to polynomials, right? So let's go back to see chapter 9 here, quadratic equation and function. I thought this we teach that part at algebra in the last couple weeks. I'm gonna like go through that one more time, right? Let's spend some time here one more time. Someone still there was just joining? First. Okay, hopefully not missed. Okay, so let's focus this one right now. The quadratic equation. Quadratic equation is have the general description is right here, like this one. Okay, like this one. So it's like this kind of description. And earlier, before we move on quadratic equation, we often talked about polynomials, right? Like this part equals 0, right? You guys can know this part. We talked about this part equals 0. So how to find the solution of this one? We introduce thing called zero vector theory, right? Suppose say that's C times D equals 0. So at least one of the factors should be 0, right? Just like that's two number, the product of these two get 0, and at least one of the factor would be 0, right? So is C equals 0 or D equals 0? And use this part. So like this one right here, they didn't factor yet, right? So we need to factor this part. And how to factor this part? You know, guys, you guys know that one, right? Something like quick question. Let me give a quick kind of example here. So like this one, everyone knows what we initially say can be factored into, can anyone very familiar should be, this one can we run it into like this. So actually this part is like two factor, right? So we can make use the theorem here, make this one equal 0 or make this part equal 0. So you can get one of the answer is -1 or second answer will be -1 as well. They are equal to each other because of this is perfect square, right? So if so this one you can factor based on based on several methods. Actually, we earlier introducing several different methods. But right now, I will not talk here. But maybe you can, in near future, you will often need to face on how to factor these kinds of expression, especially sometimes judge if they are potentially have no solution of here. So how to judge these kinds of expression, if they have answers. So we introduce thing called discriminant, right? Discriminant. For discriminant, based on here, we use the coefficient of the x squared coefficient of x and the constant number to judge the discriminant. Discriminant, how we describe? So b squared minus 4ac, right? So to judge this part, if they are greater than 0, they have two solutions. If they are equal 0, they have only one solution, like this part, like this kind of example. So b equals 2, right? B equal 2. For a equal 1, c equal 1. So finally got 0. So you have one solution. Actually, they have theory is say two solutions, but they have equal to each other. When the greater equal one have two solutions, but they are different to each other. Right? So if this discriminant is less than 0, we say no solution. No solution. I think someone joined me. Sorry for miss that part. Already joining? Okay, sorry for that one. I missed. Did someone talk here? I missed someone. There's someone joining. Please talk, okay? Because sometimes I cannot come back to check so frequency. Okay, so you can see here the discriminant. What's discriminant here? Is the part actually often using. So keep this in mind. Make sure you write down and remember. Okay, this is very important. So we also use these kinds of information in the quadratic equation and function. Actually, function. The function part actually is somewhat transformed from the quadratic equation, right? Right. So general expression of quadratic function will be like this here. So you can see here when we often like to graphing how to graphing this one, and when we do graphing, so we often like to list some of the dots, special dots on the line, right? When x equals 0, it's equal c. So it will be equal c. You can see this is y-intercept, right? When y equals 0, what x will be? So this one will be transferred into what? Transfer earlier, what I talked about became quadratic equations, right? We need to find out if they have answers. If they have two answers, means here have the x1, right? If they are based on discriminant, if they are greater or equal 0, they have 1 dot. Right? So based on these kinds of dots, so this 2 actually is what? Is x-intercept, right? Is x-intercept. And this one is y-intercept, right? So we can find out. We can get a better way to get a chart. So let's give these examples here, right here. Let's see this one. So, all right. So some people like to do some transform. Some people like what I do list tables. But when you do the SAT text, they don't give you enough time to do these kinds of details. So you need to be very familiar with this process, right? So you can get x0, y got 3, right? When y got 0, what would it be? Maybe yes, maybe no, right? We don't know. So, but we can do something else. When x equal 1, when x 1, so you can got 6, right? When x equal 2. 4 plus 4 plus 3, so you got 11. So you can move the chart here. So 0, 3, let's move, say 0, 3, this is x-intercept. We don't know y-intercept actually. Y-intercept here is 0, 3, but we don't know x-intercept. We know the 1, 6, 1, 6 is here. 2, 11 is like here, right? Looks like here. We just do partially. If we do 3 dots, it goes like this. Looks like this goes down like this way, right? The chart will be like this, but we don't have the x-intercept yet. So we need to go back to see when the y equals 0. So it's transferring to, we find the x solutions. So we see the discriminant. So discriminant is b squared, b equal 2, right? Minus 4ac, so equal negative, yes, negative 12, 4 became negative 8. Negative less than 0. Less than 0 means no x-intercept. So what's the peak would be? So this is like quadratic, like a parabola, right? Parabola, where's the symmetric line? We need more. So it means we need to do a little bit more. We don't know where here. We don't know the peak. We don't know these kinds of symmetric line. Right? So we need to do some additional work, try to find out here. So let me do this way. So let's see, when we're graphing these kinds of quadratic equations, let's do some transform. So based on previously, we can make it perfectly square. When we give any two terms of like this, when you can find the third term, make it become a perfect square. Do you guys know how to do that? Okay, so let's see here. We know earlier this one is perfect square, right? This one can be written into like this. Earlier, some question we already talked about. But where this one come from? If you only give those two terms, how you find out this is 1? Okay, so the same thing here. If x squared, you give all this bx, what's this term would be? But let's think, we go back and we think about earlier, what do we, when we have do this kind of thing? We can see this part equal can go to x squared plus 2ax plus a squared, right? If we do this one, so if this one, if you know this term and knows this term, how to find this term? We make this number half of them, right? Find it means this coefficient in front of x, half of it, and make it a square. The same thing here. So this is the coefficient in front of this x will be b. We make it half and square. The same here. So that's the y1 come from, right? So it means come from here 2. 2 is 2 half of it and square. So it became 1 square is 1. So this is 1 come from. All right. So here you can see here is will be 1, right? But if we add 1, we minus 1. So it doesn't change anything, right? Because of these 2 will be disappear. All right. So it means this one equals to x plus 1 squared plus 2. All right. So we can find the peak here. How we find the peak? Make this part become minimum. You can see what numbers square the minimum value of a number square will be 0, right? Whatever number. The great some number square, some real number square, always greater equal than 0. The minimum one would be 0. So it means x, when x equal -1, this one will be 2, right? So would it because here means -1, because the minimum is 2. And so you can put -1 inside here. -1 squared is 1, right? Minus 2. So it became -1. -1 plus 3 is 2. So it's fine. So you can here it's 1, 2. Should be somewhere here. It's not go down here. So we can find this dot and graphing like this. Whenever graphing here, always mention what I'm saying, always have 5 items you need to find out. What are 5 items? First, we need to find the y-intercept, right? Second, we find the x-intercept. Third one, we need to find this symmetric line. What is symmetric line? So you can see, let's go back to see this one again. See here, symmetric line. So see here, we do some transform here as well. We try to find a symmetric line. That's our target. Right, you see this expression here. So if you distribute inside, you've still got a top part. So just like we say, we needed to find the third term. What the third term would be? Would be half of this part, half of this coefficient in front of x, right? Half and make it square. All right, so it would be this term. So we add a new term here, actually need time here. So we need minus this new term. The b squared plus 4a squared. This is a, right? Distribute inside it, we need to still time a. Right, so we add a new term minus the new term. So let me use this, watch the black part. So here you can go b over 2a squared. So this one will change bracket in the parentheses, right? Plus, so here a is factored out. 4a, let's move and 4a here, you can 4ac, right? Minus b squared. Okay, so we goes down. So you can see that this would be perfect square, right? M plus 4ac minus b squared over 4a. So y, let's copy down y here in the left. So you can see this mean is perfect square, the over greater equal 0. The least value out of this square is 0, right? So how to make this one become 0? It's negative b over 2a. So when x equal negative b over 2a, this part is 0, right? This part is 0. So make this part minimum or maximum, depends on a value. If a is positive, this is minimum. If a is negative, is maximum. Okay, okay, so the final goes to chart here. So this is the symmetrical line. In the left part, in the left, so this is a symmetric line. Whenever give you the quadratic function, this symmetric line always equal negative b over 2a. Right? So symmetric line x equal negative b over 2a. The third, 1, 2, 3. And what about the other two? What about the other two? The peak, right? Yes, it's the peak. What's the peak? Peak is the peak always a line on the symmetric line. So x always negative over 2a. So you can see when we put this data here, make this value, so this will be y, right? So here is 4ac minus b squared over 4a. This is the y. This is symmetric. So basically, you need to identify the coefficient of a, b, c, and a. So you can determine this p. Where's the number 5? Number 5a. Actually, we talked about mouth. When you graph this one, sometimes here, sometimes like this, right? Mouth open up and down. So it depends a. If they greater 0, mouth open up. If they less than 0, mouth will be goes down, right? This is up, this is down. So whenever cancel quadratic function, basically you need 5 things: x-intercept, y-intercept, symmetric line, the peak, and the mouth. Right. So actually, let's summarize. Let me get rid of all this busy writing here first. No, I just make it invisible. So you can see actually this is the summary. So you can see they are already summarized here. the summary is not so good as what I have, right? So you can see here is x-intercept, two of them, a symmetric line, the vertex, so 1, 2, 3, they describe here already. They didn't mention here was the 4 in mouth opening down, 5, right? They told you was how to get at least 2 solutions in the x-intercept. That's good. This part is good. All right, so let's review this one. Keep this in your mind. They take you several different ways to check your questions. Something they ask you, what's the y-intercept, what's the x-intercept, what's the peak, what's the vertex, and what's the symmetric line. They ask various questions, but you have to know all. You have to know all this part. So let's go on to see some more questions. So to find out how they potentially in your give the question in SAT. Let's see this one. All right, anyone take your notebook out, right, to do this one, okay? The height edge of a fireball launched from a Roman candle with an initial velocity of 128 feet per second is given by the equation. So they already told you here, right? The line, the height, and the time relationship. The initial velocity is 128 feet per second. H is the height. Here is the time. So here is time, right? Here is the height. So initially launch up, they go up just like you throw a ball, like basketball, right? You throw up, it's falling down. But like the check the check will by the times. Okay, so time is the second after lunch. Use the graph function as answer the questions. A, estimate the maximum height of the fireball. It's maximum height. So here, just like what we talked about, right? So what do we first need to do? We need to identify A, B, C, right? Or you can do some changing. Or they already graphing here. So you may estimate it by the graphing. Graphing maybe not right. So we do some same thing as what we do. As what we earlier talked about. So we negative 16, we take it next 16 out first, T. Here's what? So here is changed to 8, right? Minus 8. Is it correct? 128 or negative 16 T. Right? That's all. So we do some change in perfect square, right? 16. So here is plus what? It's 8 divided 2, right? Actually, it's negative 8 divided 2, 8 makes square. So here is 16. 16, we need to take it out. Is plus 16 times 16. Is it correct? So let's do a little bit, try a little bit detail, try a little bit simplify. Is it correct like this, right? So plus 16 times 16. All right, so here is 16, here is t minus 4 squared plus 256, 16 squared, right? All right, so you can say h equal like this. Well, so what's the maximum height? When the maximum height, it means this part becomes 0, right? This one, if they are positive after negative, and plus here is much smaller. So the maximum of this one is 0. The negative, it became h maximum. So when the t equals 4, h get the maximum, right? Like what they draw here. This is not exactly 250, a little bit higher than 250. So h equals what? 256 feet, right? Answer the first question. B, estimate the time whether the fireball at its maximum height. So it means t equals 4 seconds. We get answers right here, out of here, right? Estimate the time when the fireball return to the ground. Return to ground here. So here is 4, here is 0. Just like say the distance here is same. Take 4 seconds to get the maximum. Take another 4 seconds, go to the ground. But actually, we have another way to do the work. We already know this part, right? We can factor here as well, right? This times, not minus. I'm sorry. I'm not right so good. So when layer h equals 0, it means at the ground. So we see the factor here, 1 factor, 2 factor, 3 factors. So this factor equals 0 means at the beginning. What about this part? Equals 0, so t equals 8. So it means return to the ground. Match up here. Right? So you can get 8 seconds, go to the ground, 4 seconds, go to the maximum, highest, what is 256 feet. Is that correct? All right. Move on a little bit. Let's see some more questions. Let's take one more questions. Did everyone can catch me what I'm talking about? If everyone gets no? Yes?
Yeah.
Okay, well, great. All right, let's see this question. The average price of gold in dollars per troy ounce from 2001 to 2005 is given by the equation. So you can see this is quadratic equation. In function, actually. In this equation, x is the numbers of years since 200 to 2000. Assume that the trend continues and find the first year after 2000 in which our price gold will be 658 per troy ounce. The troy ounce is a little bit over 50 grams. 15 grams. Okay, so I put the answers there, we copy the answer there, but let's see how we get out. So here, so you can see this one, right? So the answer would be when y equal this number, what it will be. So I just put it back in directly. That's a bit easier, right? 658 equal. So I missed here. Okay. Right. So we just, let's move everything to the right part. So here, so will be changed to what? Negative. Negative what? What? Do you guys know what? That's so 440, right? Right. Both sides times -1. So we can change here, or everything moves to the left part. Right? So you got this equation. Actually, it's find a solution here now. Okay, so what's the question will be? Find a solution. So actually, we try to factor this part and got 51, right? So you can maybe 44 times 11. You can get 51. Do you know how to get this one? Everyone knows how to factor this one, right? Try to factor this constant number first. Got it into 2 factors. And then sum of these 2 to match this. So actually, you can see here, get minus 11 minus 4 is 40 times 11, 40 times 11. But 0. So first is 11, second one is 40. So in between 2000, after how many years the gold was 600, so it means 11. The closer is with 11. So after 2000, after 11 years, it will be 2011. Right? So here actually just try to question you how to factor. That's the most challenging part for you guys, maybe. Sounds good? Okay, so we still have 5 minutes. Maybe we can cover one more questions. Let's go down one more, okay? Now, this is close to what we had earlier. Let's do some a little bit more change. And a lot of questions looks like close, but let me go jump a little bit further, go a little bit different one. I don't like to repeat the same questions, a little bit different questions. All right, so let's see it here. Solve linear and quadratic system. There's one is the quadratic is parabola, the other is linear line. How to find the intercept? So we can imagine here. So something like this one, when you graphing, right, the y. So here we can do some proper transform. X squared plus 3x plus what? Make it perfect square. 3/2 square. All right, we minus the again. This is 9/4, right? Plus number and minus the same number. Then copy 5 back. So we change into here. This is perfect square, right? This is 3. And the last one is 4, 20. So 29 here. So y. So this means this one changed to like this. So everyone can graph in here, right? Let me make this one a little bit easier. Change the colors. So symmetrical line is right here. Is -3/2, right? Here is x equal -3/2. Y is here is -29/4. Let me give a dot here, some close here. Right. So they potentially like this, and negative and y equals 0, -5. This is y-intercept. And some more dot have a balanced dot y here. So you can get a chart probably like this, about like this, okay? I don't need to go exactly what we have. And what about this line? This line is plus the 0, 3. 0, 3 is around here, okay? And it's always 1, so we'll be close like this. So here is -3, 0. And here is -3/2, right? So a little bit right side, left side of here. So you can see they definitely have 2 dots. So it means have 2 solutions. We need to find out what's this. So you can see the parabola line like this and a linear line like this. What it will be? So whatever the word will be, the y is the same. So it will be transformed into. Let's go back to see some question here. Okay, what's others? We're going to choose some different colors, make it easy to judge. So actually became equation. So we make y disappear, just substitute here, substitute the first question to the second, to the first equation, second equation, substitute in the first equation. So you can build is x plus 3 equals x squared plus 3x minus 5. Right? So we eliminate the y. Right? We change it, move everything to the right part. Combine like terms. Right? So we'll change like this. So this will be easier for us. Everyone can factor this one, right? This one factor into positive 4 times -2. Sum of these two got a positive. So it's became positive. One of the answer is -4. The other answer is 2. Right? Is that correct? So it means this dot will be -4. Don't know why yet. This one is 2. We don't know why yet. Right, that will be easy, right? So we replace here with 2. Here got a 5. Replace here. Here got a -1. This is pretty decent. They have 2 dots. One is -4, 1. The other one is 2, 5. Let's note. Let's make sense about what we got, right? Sounds good. Okay, so what the new topic here is we go through the quadratic equation system and they have intercept. Additional one, I want to add a little bit more here. Something like if this linear line is moved down, you can move up, you always have 2 dots. For a parallel, you can do a parallel move this linear line to this way, okay? So always have 2 dots. When you move down here, you can see they are almost closing, and never, they are only one dot. They would maybe ask us, say, okay, this is y equal x squared plus 3x minus 5. The other y equal x, move this c. Okay, we don't know this number. Well, these two only have one solutions. Yeah, they only have move down, only exactly have one. Move down here, only cut through, exactly only cut through. What c would be? Okay, so we can do the equation like this. Right? Okay, plus 2x minus 5 plus minus c equals 0. They have only one solution. So it means perfect square. When it became perfect square, so it means negative plus minus c equal 1, right? Perfect square here need 1, make it perfect square. So c equals what? C equal, move c to the right, move negative 1 here, so became negative 6. Right? So when y equal x minus 6, in this line, this only have one dot. When the c is even lower than 6, if you continue move down, these two parts like separate, right? This parabola and linear line will be separate. It's further separate. It's interesting, huh? So maybe you already learned in the algebra too. But this just like how to find the solutions. Okay, so today I will send out some additional questions for you guys to practice, but additional practice part with the SAT Math 3, I believe. You can just continue to practice, record time, use the challenge questionnaire, and we come back to talk. Sounds good? That's all for today. All right. And can you please leave the question and mark time turn it in Google Classroom? Don't forget to take a picture of your homework and send. Just take a big picture. If you write down your notebook, take a picture of your notebook. If you write down on the print out words, you spread out and list the answers like Daniel doing and send to the Google Classroom. Sounds great? Sounds good? Everyone give me an answer. Say yes. Powerful answer.
Mm-hmm.
All right. Thank you, everyone. So see you next week. Have a good weekend. Okay.